warm welcome to all. Today we will talk about another important topic. It's called indicators in pH. The objective of the talk is to define what are indicators, what are different types of indicators, how it helps to distinguish between acids and bases, and a very important concept of pH. So let's dive into this topic. Let us again recap what we talked about last class on concepts of acids and bases. So we again define acids as substances which when reacts with water gave rise to hydrogen ions. For example, hydrochloric acid is an acid. This forms a hydrogen ion. Similarly, we define bases as substances which reacts with water gives rise to hydroxyl ions. So sodium hydroxide is a base. This is in continuation of the last class of concepts on acids and bases, and you can please go through this class also. But the big question is how we distinguish acids from bases. There's a big question, and this brings to our today's discussion on the role of indicators. So let's go deep into these concepts. So what are indicators? So indicators are substances, that refers to the substances which that changes color order, that substances that changes color order on contact with acids or bases. So three things to be known: they are substances, they change color or order on contact with acids and bases. So what are the types of indicators? There are three types of indicators. One is the natural indicator, second is the synthetic indicator, and third is the olfactory indicators. So what are natural indicators? Now, natural indicators are found in nature. For example, litmus is a natural indicator. We'll go deep into this one. We also have a cabbage, turmeric, and China rose. The next is the synthetic. Synthetic indicators are those which synthesized in a laboratory, like methyl orange, phenolphthalein. And the third indicator is called the olfactory, like onion and vanilla. So the first indicator we talked about is the litmus. So what are litmus? So litmus is derived from the plant from the lichens. Now what are lichens? For example, this is a lichen. Lichen is formed by the symbiotic combination of algae and fungi. That means lichen is a plant which is formed by the symbiotic combination of algae and fungi. So this is the litmus. So from these lichens, what we get? We get what we call litmus paper. So this is the litmus paper. As you see, you get like litmus paper. And when this litmus paper is dipped into the acidic or basic solution, so this litmus paper is dipped into this acidic and basic solution. As we see, in acidic solution, the blue litmus turns to red, and in basic solution, the red litmus, you see the red litmus turning to blue. So in acidic solution, blue litmus turns to red, and in basic solution, red litmus turns to blue. The second natural indicator is turmeric. This is a healthy which we always take in our day-to-day lives, in our cooking items. So this is a turmeric. So turmeric is an indicator. How it acts? So when you add turmeric powder to acidic solution, it turns to yellow, and in basic solution, it turns to brown. As you see, in an acidic solution, it turns to yellow. In basic solution, it turns to brown. The third natural indicator is the red cabbage. We take cabbage in a food item. So this is a red cabbage. Now how it acts in the indicator? Now when you make red cabbage a solution, for example, we made a solution of red cabbage, and when you put this red cabbage solution in an acidic solution like hydrochloric acid, so what happens? It changes to red color. So red cabbage in an acidic solution turns to red color. So what happens now when you put the same red cabbage solution into a basic solution like a ammonium hydrochloride? So what will happen? It will turns to yellow. So acidic solutions turns to red, basic solutions turns to yellow. So this is how it changes the color. Third is another natural indicator, China rose. China rose is a flower. This flower is from the flower of hibiscus family. Now when you put the petals of this China rose are dropped in warm water, so when you put the petals in warm water, we see a color change, a pink color change. Now when we put this warm pink China rose solution into an acidic solution, acid solution, it turns to what? Magenta red. So since this turns into a magenta red solution, and in basic solution it turns to a green solution. So acidic solutions, in acid it turns to magenta red, and basic solutions it turns to green. Second indicator we talk about is a synthetic indicator, which is synthesized in the laboratory. So synthetic indicators are two only. There is a phenolphthalein and methyl red. So in phenolphthalein, in acidic solution it remains colorless, whereas in basic solution it turns to pink. Whereas methyl red, in acidic solution it turns to red, and in basic solution it turns to yellow. We talk about is the olfactory indicator. Now what are the olfactory indicators? Olfactory indicators are all indicators which changes odor in presence of acid or basic solution. So as you see, what are the olfactory indicators? Is an onion. Onion is an olfactory indicator. Secondly is a vanilla extract. Now when you put onion in an acidic solution, it retains the smell, whereas in basic solution it loses its smell. Similarly, in vanilla extract, when you put vanilla extract in acidic solution, it retains the smell, it remains same, whereas in basic solution it loses the smell. So as you see, in acidic solution retains smell onion, basic loses smell, vanilla retains smell, loses smell. Then but there are some disadvantages of indicators. So what are disadvantages indicator is that indicators only tells you about the presence of acids or bases. So only tells you about the presence of acids and bases. But indicators does not tells you about the strengths of acids or bases. So it never tells you about the strengths of acids and bases. What is the strength? How much is the strength of acids and bases? So in order to, here comes the very important concept of what we call the pH, and here also comes to the another concept of the important indicator, which is we talk about is the universal indicator. So firstly, what is pH? Now pH, as you see, what is pH? pH, the word P of the pH is derived from the German word means potence. P derived from the German word potence. Potence means power. So when this P word power is combined with hydrogen, so when this P potence power is combined with hydrogen, it forms what we call the power of hydrogen, or called P. That is, the P when is combined with hydrogen gives rise to power of hydrogen of pH. So what does pH measures? pH measures the strength of, it really measures the strength of the hydrogen ion. So remember, it only measures the strength of the hydrogen ion in a solution, hydrogen ion solution, and the pH of the solution is given by Sorensen, a formula called pH is equal to a negative of log of hydrogen ion. So please look at this equation. pH is equal to a negative of log of hydrogen ion. So what does it mean? So it means that if the hydrogen ion concentration in solution increases, the pH decreases, because it's always a negative part, and this solution becomes an acidic solution. So hydrogen ion increases, pH decreases, this becomes an acidic solution. Similarly, when we look at the another thing called, when hydrogen concentration decreases, the pH increases, and this is called the basic solution. So hydrogen increases, pH decreases, hydrogen decreases, pH increases, because there is always a negative log of it. So but the question is, what happens if in any solution we don't know the hydrogen ion concentration? So we know, suppose we know the hydrogen is fine, but if we don't know the hydrogen concentration, like this hydrogen we don't know, so how we determine the pH of the substance? Here comes the role of the universal indicator. We have to take the help of the universal indicator. So what are universal indicators? So definition indicator is the mixture. Again, we'll look three things. It's a mixture of several different indicators. So which gives different colors at different pH values. Remember, three things: different combination, different indicators. These giving rise to different colors at different pH values. So the universal indicator, for example, this is a universal indicator. So this universal indicator is a combination of four indicators: methyl red, thymol blue, phenolphthalein, and bromothiamine blue. So methyl red, thymol blue, phenolphthalein, bromothiamine gives rise to the universal indicator. Now from universal indicator, so what we do is that we make a solution is prepared. This is a universal indicator. We make a solution. Solution is prepared. Strips. Next, we take the strips with desired substances are dipped in the universal indicator. So when strips, we take a strip containing the desired acid and base solution are dipped in the universal solution. Then, based on the substance containing acids or bases, there will be a color change in the indicator. For example, these strips will show a color change when we dip in the universal indicator, and from this color change we compare this color with the help of the pH scale which is present along with the universal indicator. So this is the strip showing different color changes, and we take help of a pH scale which is present along with the universal indicator. Now as you see from this pH scale, we find that there are some numbers from 0 to 7 and from 8 to 14. Now as you see from 6, when it goes to 0, the color changes from green to red. So this is called the acidic pattern of the pH scale. And as you see from the other side, when you go from 8 to 14, there is also a color change from green to violet. So this side is called the alkaline side. So based on the color change, we can determine which side of the pH it is. Suppose we get a color of the pH as red, so we mean that this is a very highly acidic solution, or we find that the solution is purple, so it is highly basic solution. And 7 is the neutral pH of the solution. So this is how we can determine with the help of the pH scale what is the strength of acids and bases. Now there are some common examples of the universal indicator. As you see from this scale, as you go from 7 pH to 0, we find a wide range of acids. Like we see gastric acids commonly present in our stomach has a pH of 7. A lemon juice has a pH of 2. But as you go down from 7 to 12, we find 14, we find that the egg has a pH of 8, which is an alkaline. Baking soda has a pH of 9, and soap has a pH of 12. So this is how a universal indicator helps us, and pH scale helps us to know what is the pH of the substance. So in the next session, we'll know how we calculate the pH. Thank you so much. Please continue to subscribe my channel. This will give me a lot of confidence to give newer ideas and views. Till then, take care. Thank you so much.